Last time I introduced Python, and I showed you some of the neat features of the language, and gave you some examples of things Python can do. We talked about loops and variables and all sorts of great things. And we also talked about, at the end of the lecture about using CGI to process forms from a web page. But last time, we sort of ended with this idea that we can fetch values from the form using the field storage class. And I had an example. I think this was the same example here, in fact. Basically, we fetched the name field from a form, and we printed out your name is. So not very powerful, not very interesting, not very exciting. Today what I want to do is look a little bit further into what we can do with Python as a backend, as a way to write scripts that actually process data from the form. So let's start by looking at a way that we can use what we've learned to make a simple sort of calculator. So here's a little bit of HTML code. It's not the complete web page. I'm just giving you the body section. And it contains a form. And the form is going to trigger a script named calculator.cgi. How do I know? Well, if you look at the form tag, it has an action attribute. And that action attribute is assigned the value calculator.cgi. That's the file name that is going to be loaded when I click the submit button. And we're going to pass information to that script, calculator.cgi, using the post method, which you'll remember has some advantages over get. And we're going to encode it using the multi-part form data encoding. Inside the form, I have my form elements. And I've given two input elements that have labels. One is labeled X and one is labeled Y. And following the X label, we have a text input. It's actually a number input because it's a special kind of text. It's a numeric input named X. And we have another input named Y following the Y label. Notice I've used break tags to put them on separate lines of the web page. And then beneath those two inputs, I have four more inputs. And these are all inputs of type submit. So the important thing here is that I don't have to have a single submit button. I can actually have four different submit buttons in my form that do different things. In this case, because I'm implementing a sort of calculator, I'm going to have one submit button for adding, another submit button for subtracting, a third submit button for multiplying, and a submit button for dividing. So if you display this in your web browser, you get something that looks like this. I've added a little bit of CSS here to make it a little prettier than just the raw HTML code. I'm not going to bother to show you that because by now you should be very familiar with how CSS works. Notice I've got my X label and my input for X. I've got my Y label and my input for Y. And here I've typed the number 30 in for X and the number 7 in for Y. And below my two number inputs, I have buttons for adding, subtracting, multiplying, and dividing. So suppose that I were to click on the multiply button. Well, that's going to trigger the script. And here is my calculator.cgi file. Notice at the top I have my magic, shebang user bin Python. Beneath that, I import the CGI module. We're going to learn later in this lesson about how to create our own modules. And then I fetch the form fields using cgi.fieldStorage, and I'm going to put them in a variable named f. So when I talk about f, I'm talking about the data that was from the web form. I'm also going to create some variables, and I'm going to create a variable for x, for y, and for the result, which I'm going to call res, or res. Initially, I'm going to set them all to 0. I'm going to then fill them in with values from the web form and do the proper calculations and then generate a result page. So I check if the form has the key X. And it should, because if we go back to the HTML, I have an input of type number that had the name X. That name equals X tells my script that anything the user types into that number field is supposed to be named X. And I can get it with has key X. I can check if it's there. And then I can say f sub x dot value. We're going to see in a little bit there's an easier way to get the value. Then I'm going to do the same thing for y. And I'm going to put it in the variable y. And so now I've got my numbers in x and y. So I think I put a 30 in x and a 7 in y. Those numbers are now in my variables in the Python script. Now I want to use the has key function to see which submit button was clicked. Was it the add button, or the subtract button, or the multiply button, or the div button, which is the divide? So I can use if f.haskey of add to check if we were supposed to add. And if we were, I'm going to put x plus y into my result variable. Instead, if they didn't click add, if they clicked subtract, then the subtract field will be in my form data and not the others. And so I can do x minus y and put that in my result variable. Similarly, I can check if it was the mul button or the div button. I have to do things a little differently for division because I don't want the program to crash if I try to divide by 0. So first I check if y is 0. If it's not equal to 0, then I set the result equal to x divided by y. But if y is 0, I'm just going to set the result to 0. I know that's not correct mathematics, but for the purposes of this example, it was the simplest way to handle this error condition. In real code, you would throw an exception and have some sort of function that prints an error page. Once I've calculated my result, I now have to print an HTTP response message that will be displayed in the web browser. So remember, the HTTP response has two parts. It has the HTTP headers, and then it has the payload, or the body of the message. So first I print content type, text plus HTML. That's my HTTP header. I'm only going to put that header in my reply. And then I leave a blank line, and I have to leave a blank line to separate the two parts. And then I can put the body of the web page I want to produce. Notice I've got my doc type tag like I always do. I've got my HTML tag like I always do. I've got a head and a title tag. And then I've actually left out my body tag here. That's embarrassing. There should be a body tag. And then I have a paragraph tag with some bolding inside it. Notice that I used triple double quotes for this so that I can wrap multiple lines. And when I want to put my variable in, my result, I just put triple double quotes in to stop the string. And then I use plus, which for numbers is addition, but for strings is concatenation. And concatenation, again, means add to the end of. So I'm going to add to the end of my string the result string. I cast it using the str function just to make sure it's still a string, because it was a number, right? I make it back into a string with str. And then I put a plus, and I put my triple double quotes again to start a new string that contains my /b tag and my /p tag, my /body, /html. And I use triple double quotes at the end to say, OK, now I'm finally done with the web page, and I'm done printing. So my opening print after the print is closed at the bottom of my message. So this will print a web page that says the result is, and then in bold, it'll put the number, which should be 210, because 30 times 7 should be 210. And that looks like this. So the main reason that we use HTML forms is so that we can have persistent data. We want to be able to store information on the server so that other people can see it too, and so that it's there after we log out, so that when we log back in, we can still interact with that data. So in order to do that, we need either to use a database or to use files. We're going to learn more about databases later in the course, but for now we're going to just use flat files or text files. So Python allows us to do that. We can open files either for reading, writing, or appending. To open a file for reading, we do something like this. I'm going to name the file data, and I set it equal to, and I use a function named open that opens a file. Open takes several parameters, but most of them are optional. Really, the only required parameter is the file name, which in this case is going to be data.csv. However, I recommend that you always provide at least one other parameter, which is just a string, and it contains one of the letters R, W, or A. R stands for reading. So we're going to open data.csv in reading mode, read-only mode. By the way, CSV stands for comma-separated values. That's a kind of spreadsheet file. It's really commonly used for exporting data so that scripts can process it. So Excel can export to a CSV file, and your Python script can read it and do all sorts of cool and interesting things with it. It's a lot harder to do that with an XLSX spreadsheet file, because it has all this extra metadata about the fonts and the bolding and other stuff that we don't really care about if we just want to do data analysis. We can also open a file for writing. So here I have an example of that. I'm going to create a file object named record using the open function. I'm going to open the file named records.txt for writing. And so I use W for writing. I can also open a file for appending. So here I'm opening the same file, records.txt, but I use the A flag that'll open it for appending. The difference is that if I open it with a W flag, Python will delete everything in the file. So if there's already data in the file, W will delete it and start a new file. But if you open it with the A flag, it'll keep what's already there. And when I write to the file, it's going to add information to the end of the file. So it's going to append to the end. So once we've opened the file, we can do different operations on it. And the important ones are reading, writing, and closing the file. So there are two different ways I can read in Python. There's a read function, so I can say the name of the file object .read, and it will read the entire file into a big, huge string. A more useful way to read data is to use the read lines function, which instead of reading all of the data into a huge string, will take the entire file, but it'll split it up into lines, and it'll make a Python list of lines, where each line is one string in the list. This can be a lot more useful. If I have, for example, a comma-separated value file, a CSV file, typically the rows of the spreadsheet are the lines of the file, and we separate the columns with commas. So I can get the different rows of the spreadsheet just by using read lines. And I've got this nice data structure that contains the information that I need. If I want to write to a file, I can do that too. I say the name of the file object, so maybe record dot, and then write. And in parentheses, I put the data to write. And it's just a string, and I can write that string directly into the file. If I write, it writes it byte for byte. So it's exactly the string I give it. It's not going to add any line breaks or anything like that unless I specifically put line breaks in. We'll see how to do that in some of the examples in a minute. When you're done with a file, you should always close it with the close function. So I could say record.close. There's two reasons that you should do that. One reason is that if you don't do that, information can leak. We can be using up resources that we don't need. And another reason is that if you don't close a file, information that's been cached in memory but hasn't actually made it to the disk may be lost. So there's a lot of reasons to close things. Another reason is that it's just good programming style to clean up after yourself. But don't forget to close your files. So Python provides us with access to files, but it also allows us to take the strings that we get back when we read the file and split them up into pieces and do interesting things with them. So there's a couple functions that you need to learn that are really important because we use them over and over in Python to process information. And the most important one is called split. Split takes a string, which might be one line of a file or maybe multiple lines of a file, or it could be some input from the user. But it takes that string and it splits it up into a list of words. So if you call split all by itself, just whatever the name of the string is, .split with empty parentheses, it'll split on the white space. So for example, if I make the string, this is a test, and notice I've got some spaces in there, and I've also got a tab between is and a, and I call .split on it, split returns a list containing the word this, the word is, the word a, and the word test. So it'll take out the spacing and just give me a list of strings containing where each string is one of those words in that message. I can also split the string into pieces using some kind of delimiter. So if I pass a string to split, like a string containing a comma, it'll actually split the string into pieces separate where it used to be separated by commas. So for example, if I have the string George Mason, comma, 23, comma, male, comma, armed and dangerous, and then I split on the commas, I get back a list that has George Mason for the first string, but then it sees the comma and it stops, and it gives me the next piece, which is 23. Then it sees the next comma and it stops and splits, and it gives me the next string, which is male, and then it gives me armed and dangerous. So it takes the commas and it splits the string wherever it sees a comma and gives me back a list of these pieces. Again, if you're parsing a comma-separated value file, this is a great way to get the pieces, the columns of the spreadsheet. There's a lot of other uses for this. You could split on the colon. So if you have some kind of list that has a name, colon, and age, or something like that, you could split on the colon and get the name in one piece of the list and the age in the next. You could split email addresses on the @ sign to get the domain and the username into separate strings. So this is really useful. Another function that we use is the strip function. The strip function removes white space from the beginning of a string and the end of a string. Sometimes when data is coming in from a file, there's extra spaces at the end or at the beginning and we want to clean it up, so we can just call the strip function, and it'll throw away all that extra space, leaving just the non-white space characters, the letters, the numbers, the symbols, things that aren't spaces. If you only want to remove white space from the right side of the string, the end of the string, you can use rstrip instead. So that's also useful. This is especially important if you're comparing two strings, because if I have the word sled and I have the string space space sled, I probably want those to compare as equal. But they aren't equal in Python's eyes. The computer doesn't think those two strings are equal because this one has spaces and this one doesn't. But if you strip all the white space away and then compare, we remove the spaces, so it's just sled compared with sled, and it'll compare as equal, which is useful. So here's an example. Suppose I've got a comma-separated value file containing this weather data. On June 12th, we had 1.2 inches of rain, and it was 80 degrees. On June 13th, we had 0.0 inches of rain, and it was 85 degrees. On June 14th, we had 0.2 inches of precipitation, and it was 76 degrees, I guess for the high maybe. You don't have just one temperature during the day. June 15th, 0.3 inches of rain, 74 degrees, and you can see what the data is for June 16th. So this isn't real data, I just made this up. But we want to take this file, and we want to calculate maybe the average temperature and the average amount of precipitation. So here's how I would do that. I'm going to open a file named weather.csv for reading, and I'm going to put it in a file object named data. So data gets open of weather.csv, r is how I open the weather.csv file for reading. Then I'm going to read all the lines of the file into a list named lines. So lines gets data.readlines. Data, remember, is the name of the file I just opened. So I'm reading from the data file all the lines and calling them lines. Now I'm done reading from the file because I've read everything, so I close the data file, data.close. Now I have all of the lines of data. I need to loop through them and parse them. But first, I need to set up my variables, because remember, I want to calculate the average temperature and average precipitation. And in order to do that, I have to add together all the temperatures and add together all the precipitation amounts. So I'm going to create a variable named sumTemp that represents the sum of all the temperatures. And initially, I'm going to set it to 0. And I'm going to create a sum variable for the precipitation and set that also to 0. So once I've done that, I can loop. So I'm going to loop by using for line in lines. That says loop through all the lines of the file. And as you go through them, call the line you're currently on line. Now I can use the split function on the line string to split it where there are commas. And I can do a neat little trick here. If you remember, Python provides a data structure called a tuple. Since I know that in my data file, every row has exactly 3 columns, and they're separated by commas, when I split the line into pieces, I'm always going to get exactly 3 pieces. So this is a way I can say, put the first piece in the variable named date, the second piece in the variable named precip, and the third piece of data in the variable named temp. So I've got the date, the precipitation, the temp from the current line. And so this is a really cool trick. Then I take the temperature that I just retrieved, I convert it to a number, an integer, and I add it into the sumTemp variable. So sumTemp plus equals int of temp will convert temp to an integer and add it into my sum. I do the same thing for the precipitation amount. I convert the amount of precipitation. Actually, I'm converting it to an integer here, which doesn't make sense. I should be converting it to a double or something. But then I add it into my precipitation amount. The way I've done it, it's going to round down, which is terrible. But it's an example. OK, so after I complete my loop, I've added all the temperatures together. I've added all the precipitations together to calculate an average. I take the sums and I divide by the number of data points. I can get the number of data points by looking at the length of the lines list. So here I print average precip colon. Then I close my string. And I add or concatenate str of, that's to convert it to a string. I take the sum of the precipitation values and divide it by the number of lines. That'll give me the average precipitation amount. And then I do the same thing in the next line for the temperatures. But of course, in a real data file, I wouldn't just have the numbers. I would have some sort of row at the top that had headers that told me what each column was for. So maybe I would have a line that looked like this: date, precip, temp. And if I have that, it's going to goof up my script, because date isn't a number, precip isn't a number, temp isn't a number, but it's going to try to add the word date. Oh, actually, it's not going to try to do that. It's going to try to add the word precip into my precipitation total and the word temp into my temperature total. This is a bad thing. So I need to tell it to skip that line. And in Python, that's very easy. All I have to change is one line. When I read in the lines, I have to tell it not to put all of them into my lines variable. And I can do this with what's called slicing. All I have to do is put square brackets after my readlines call and tell it don't start at line 0, start at line 1. Remember, line 1 is my second line because in computer science we count from 0. So the first line is line 0. So if I say 1 colon in square brackets, that will say starting from line 1, take all those lines and put them into lines. So lines will not include that first header line, which is what I want. OK, just as I can read from a file, I can write to a file. Here I'm going to actually fetch some data from an HTML form, and then I'm going to save it to a file. So in order to fetch data from the form, I have to import the CGI module. And then I can say f gets cgi.fieldStorage. Basically, I'm getting the form from the web page, the form data, and I'm calling it f. And then I told you before I would show you an easier way to get values out of a form. Before we were saying if f.hasKey of name, and then I would say f, and in square brackets I'd say name, and then I'd say .value. You can still do that, but an easier way is to use the getValue function. This is a newer and better way to do CGI access. So here I say name gets, and I say f.getValue of name. That will get the name value from the form and put it in name. I do the same thing to get a weight and an age. And then I open a file named health.csv, and I'm opening it for writing, but the particular kind of writing that appends to the end. And I'm going to name that file output, so anything I do to output will go to health.csv. And the first thing I'm going to do is write one line. I'm going to write the name, and then I'm going to write a comma, and then the weight, and then a comma, and then the age. And then I have to tell it to put a line break to go to the next line. And so I have to add a new line character, and I do that with \n. That's the Unix way of saying a new line. In Windows, you have that too, but you have to put an extra character in front of it, a carriage return, \r, which is a leftover from the days of typewriters. It's stupid, but that's what Windows does. The nice thing is that Python knows that, and if you're running this script on a Windows server, it'll put in the \r for you in front of the \n, so you don't have to worry about it. This code with just the \n will work on either operating system. And when I'm done, I close my file. And then, of course, I have to print some kind of result page, because when I send an HTTP request by submitting a form, the web browser is expecting a response. And that response should contain a web page for it to display. So I'm going to print content type text HTML, which is my HTTP header, a blank line, and then a web page. And all that's in that web page is a sentence that says successfully added to the health survey. Now, I mentioned before that it's really important that you close a file. If you don't, it's going to tie up system resources. The operating system has to set aside some memory for managing that file. And if you don't close it, that memory is in use, and other programs can't access it or use it. So if you close a file, that memory gets freed up, and other things can use it, which is good. Also, if you're writing to a file and you don't close it, that information may not actually make it to the disk. It may be only saved in RAM, and if the computer crashes or something, it's not going to be saved. So this is so important that new versions of Python provide a better way to open a file that makes sure that no matter what happens, any kind of error, the file will automatically be closed. And we do that with the with keyword. So you say with, and then you open the file, and then you say as, and put the object name. So here I'm saying with open health.csv, comma a, as output. This is sort of like saying output gets open health.csv, but the difference is that now I'm going to tab over my code, and everything I do in that level of indentation is going to be done with the file open. And when I'm done with the file, I just stop indenting, and when Python gets to the end of that code block, it's going to automatically close the file. So here I open the file, I write to it, and now I'm done with the file, so I just stop indenting. I don't have to close the file myself. Python does it automatically. Kind of cool. Let's do one last example, and then I'll let you go. So here's a web page that I've created for managing a list of RSVPs. So got a bunch of people who are coming to some event. I want to keep track of their name, the name of the member, and how many guests they're bringing, and how much they've paid of the participation fee. So here, for example, George is bringing 2 guests, and he's paid $75. So I've got my list, and then beneath it I have a form that will let me add a new member to the list. So for example, if I want to say that Tom is bringing 1 guest and is paid $60, I could type Tom into the member name field, 1 into the number of guests, and I think I said $65 into the paid field, and then I could click submit, and it should add it to this list automatically. And if I come back to this web page, it should stay there because it's being saved in a file. So in order to do this, let's create some helper functions. I'm going to make a module named template.py. And in template.py, I'm going to put some Python code for generating all of the HTML that we need in every web page. And this will save me time if later I decide to make another script that produces web pages. So here I've created a function named header that takes one parameter, a title, and it prints the HTTP header, the doc type tag, the HTML tag, the head tag, the title tag, a meta tag to select the character set, which is a good thing to have. I think we mentioned that in one lecture, but we haven't used it consistently. But you really ought to have a meta char that gets UTF-8 in your code. And then I'm bringing in a style sheet named default.css so that we can have some sort of default CSS template as well. I'm closing the head and I'm opening up the body. Then I've created a second function named footer that doesn't take any parameters and just prints the /body and /HTML tags. And now, instead of typing that HTML code over and over and over in every web page I make, I can just import the template module and call the header and footer functions. This is going to save me time. So here is a script. Notice I have my hashbang user bin Python at the top, because this is my CGI script. I'm doing a little cool trick here. You can add a comment to a file, and if it's in the first couple lines of the file, and there's a double quote in it, you can put Vim commands, and when Vim opens the file, it'll automatically run those commands. So in this case, because my file is going to be named rsvp.cgi, the computer and Vim, they aren't going to know that it's really a Python file. So I can put double quote set file type gets Python, and now when I pull it up in Vim, it'll be color coded properly and indented properly because Vim will now know it's a Python file. If you want to do that, it's a useful trick in your programs. Then I import template, which is the file I just made. This is the module I just created that will give me header and footer functions. I'm also going to import the built-in CGI module that contains code somebody else wrote that lets me process HTML forms. I'm going to create a main function. And if you look at the very bottom of this code, you'll see there's an if statement that says, if the name of this program is _ main, call the main function. Web servers don't like it if you leave that out, so you're going to need to do this in your CGI scripts. In my main function, I open up the rsvp.txt file for reading. I get every line of the file into a variable named lines, and I close the file. Then I call my template header function, and I give it the web page the title event attendees. I print out my members who have replied H2 header, and then I create a UL list, an unnumbered list. I loop through each line of the RSVP file. I split it using the split function into a name, a number of guests, and a fee amount. And then I print out an LI tag containing the name, the number of guests, and the fee amount. Then I call my footer function from the template, and I'm done. Except that, of course, I'm not quite done, because I also want to have that form at the bottom, and I want to be able to process the form. So I'm going to add at the top of my main function a call to a function I've written named process form. And at the bottom, I'm going to print out the HTML for the form. So again, the action of the form is rsvp.cgi, which is also the name of the script that prints the list of members. This is a neat little trick. You can display your data in the same script that processes new data. You'll see this a lot in real websites that people in industry write. So again, I'm going to make rsvp.cgi the action of the form. I'm going to use the post method. I'm encoding it with multipart /form data. And then I have labels and inputs for the member name, the number of guests, and the fee paid, and just one submit button this time. The code for processing the form is pretty straightforward. I'm going to get my CGI field storage and put it in an object named form. I'm going to check if form has the key name, if it has the key guess, and if it has the key fee. If it doesn't have any of those, I'm just going to return. That will generate the page that gives me just the list and the form at the bottom without actually modifying the file. But if they did give me a name, a number of guests, and a fee, then I'm going to get those values from the form and put them in variables of appropriate names, so name, guest, and fee. Then I'm going to use the with idiom, the with keyword, to open the rsvp.txt file for appending. And I'm going to write to that file the name, the number of guests, and the fee amount, then a \n to go to the next line. So this will work. And if you actually go to marmerstein.org/twiddlerobert/lecture14/rsvp.cgi, you can see it in action. But really quickly, what we studied today, we can use a CGI script to read values from an HTML form using the field storage class in the CGI module. The CGI script has to print a web page that is the response that will be shown after we submit the form. Fields can actually be saved to disk and then loaded into the page from a different script or from the same script. You can use the read lines function to read a list of strings from a file, and use the split function to take a string and split it up into pieces or words. Good luck with your labs. I will see you next time.